Hi there. Today we'll be discovering the amazing world of quantum physics. Okay? And as complicated as it sounds, this is simply learning about more fundamental particles, some that are smaller than what you previously thought were the smallest, which are the proton, the neutron, and the electron. Now, it's very important that we just go through the fundamental properties of these particles before we try to tackle anything more complicated. So let's have a think. Relative mass of the proton, neutron, and electron. From your GCSE, you should remember that this is 1, 1, and with the electron, we say it's near 0, but in our case, we're going to say it's 1 over 2000, meaning it's very, very small, a very light particle. Okay? Now, the charge. What is the charge of a neutron? 0. Good. And the charge of a proton? +1. And an electron? -1. Now we come on to this bottom section here of actual mass, which is where it starts to get a bit tricky. Previously, you've only said that the masses were 1, 1, and 1 over 2000. But we're going to put some actual numbers into it so we can start using maths and put these numbers into calculations. So, make sure you write this down. We have an actual mass of the proton and the neutron are the same, okay? And the actual mass is 1.67 times 10 to the minus 27. An extremely small number, okay? Now, these numbers are very small. However, they are given to you, so you don't have to worry too much about memorizing them, okay? So 1.67 times 10 to the minus 7. And the electron, remember, is 2000 times smaller. So if you divide this number by 2000, you'll get 9.11 times 10 to the minus 31. Okay? It's very important that we get these values down because they'll be really important doing other calculations later in the course. Okay? Okay. So we've got these values down deeper. Okay? The next fundamental particle, smaller than protons and neutrons, are called quarks. Okay? Now, a quark, the definition is a fundamental particle with a mass of around 10 to the minus 28. So, thinking about it, they're smaller than the proton and the neutron. They are bigger than the electron, however, we'll get onto that soon, and we'll understand why. Okay? Now, you do have different types of quarks. The ones that you need to know, and the ones that we'll discover the properties of, are the up quark, which we'll highlight in blue. Oh. We've also got the down quark, and we've got something called the strange quark. Okay? No. Sorry, we've also got the strange quark. There we go. So we'll just make a note of these for now, but we'll understand how they build up particles and their properties later. Okay? Now, when we're talking about particles, it is important that we class them into their correct properties. Okay? And the way I like to think of it is that you've mainly got the hadrons and the leptons. Okay? You can remember which ones are which by looking at the first letter. Okay? Hadrons, we generally think of heavy. So I want you to think of the hadrons as the heavy particles. Now, if we look at our table that we did earlier, these are the proton and the neutron, okay? Now, leptons, the L in that, we can use that to say that leptons are light, okay? They're the lighter particles. So that would be the electron. There's a lot more particles than just the proton, the neutron, and the electron when we're classing particles in these two categories, okay? But the important thing to mention is that the hadrons are made of these quarks over here, okay? So these mainly link to the hadrons. The leptons are their own separate fundamental matter, okay? Now, let's imagine we have a proton, which I'll do with a plus, and a neutron, which we'll give it no charge. We'll just keep it as an empty circle for now. A quark is a smaller particle, like we said, with a mass of around 10 to the 28. And these protons and neutrons both have 3 quarks inside them. Okay? However, these quarks also have their own fundamental charge, like the proton and neutron. Okay? So the charges of the quarks in here will add up to 0. Okay? And the charges in the proton will add up to 1, plus 1. Very important that we also have our pluses and our minuses in check. Okay? So, for example, we might have 2 pluses and a minus in a proton, and in the neutron, we might have 2 minuses and a plus. Okay? And the reason we've got 2 pluses and 1 minus, and 2 minuses and 1 plus, is because of the charges and the strength of the charges in the particles. Okay? If we do a bit of maths real quickly, in a positive quark, an up quark, it's got a charge of plus 2/3, and a minus quark has a charge of minus 1/3. So if we do 2/3 plus 2/3 minus 1/3, we'll get 1 plus 1. In a neutron, we've got 1 positive, minus 1/3, minus 1/3, we get 0. So the main concepts I want you to get right now is an up quark has a charge of plus 2/3, and a down quark has a charge of minus 1/3. Thank you very much.